Hi, everybody, and welcome to another great episode of the Infrastructure as Code podcast. My name is Ohad Maizlish, and I'm your host for today. You can follow me on at DevOpsOhad at Twitter or X with its new name. And today we have an amazing guest. You probably all heard about him already. Here he is, Anton Babenko. Anton, welcome.
Hello, everyone. Hello, Ohad. Yes, it's not very often when I attend podcast, but since your podcast is called Infrastructure as Code, I must attend it.
Exactly. If you Google infrastructure as code and you go to the tab images, you'll probably just see Anton Babenko's images all over Google. But yeah, Anton is contributing to so many things around infrastructure as code. If you want a good advice, just ask Anton. He has uh, amazing knowledge when it comes to infrastructure as code, like a walking encyclopedia. Okay, so Anton, not everybody still knows about you, so it will be great if you can tell us a little bit about yourself.
Well, in regards to infrastructure as code, I started to become curious with these things in 2015, I guess. And then I discovered Terraform, and that's how I got into it. I always like to contribute to some open source things, and I like to produce some things which other people may benefit from. So I started working on Terraform AWS Modules in 2016 or around that time. I already forgot. And then I figured out that it's so much fun to work on different open source projects. So I continue exploring this and developed many Terraform AWS modules, and then try to explain this to people so that they also get value from it. And overall, I was spending large amount of time in the open source. But as you can imagine, getting paid for open source is pretty hard. Though it is possible, it is still pretty hard. So that's why I have to teach people and consult and sell hours to my customers, providing consultancy. And
I'm
yeah,
sure you.
Terraform AWS modules, and then later I transitioned into serverless because it was fun, and I figured out that this area in general was very big, very cool, very exciting for me, but there was nothing present if you're using Terraform. And that's how I started serverless TF project. And I'm still surprised that a lot of people don't know how to do this, and they still follow like official guidelines by HashiCorp or by AWS. And from day to day, they say like, "Oh, it is hard," or why it is so bad, why this is not implemented correctly. And then I need to explain to them, like, guys, please go to serverless.tf, read it, and use it, and so on. So yeah, this is my project, which is constantly missing marketing part. I mean,
So
it
we
is.
might help you a little bit with that today. So if you didn't understand what Anton said, by the way, he mentioned the word AWS so many times, which makes sense because he's an AWS community hero. He contributes so much to the AWS community. So yeah, speaking of AWS and infrastructure as code, Anton, among other projects, has two very important initiatives around AWS and infrastructure as code. You can find that in GitHub. And by the way, just to clarify how big of an influencer in the community Anton Babenko is, if you follow, if you go to Anton Babenko's GitHub page, you will see that he has more than 4,000 followers, and there's probably a good reason why so many people follow Anton. And today we're going to zoom in on AWS modules and serverless TF. So let's maybe start with AWS modules because that's like huge helper for so many Terraform developers that just want to use AWS without using directly the resources, and they want to have like prepared modules for things like EKS or RDS or VPC. Maybe before we talk about your project or uh, so many repos about AWS modules, for those who still don't know what a Terraform module is, can you please explain what a Terraform module is, Anton?
Yeah, sure. My favorite explanation of Terraform module is actually depending on who I'm talking to. Usually it is software developers. Then the easiest explanation for people who are very new to Terraform, what is Terraform module, is a library. That's it. If you go to your favorite NPM or Ruby gems or any other collection where you have other reusable libraries, that's exactly what we have Terraform registry for. So people can download this piece of code or start using it without actually understanding or learning or studying internals right away. So the biggest benefit is that people can have a very good starting point right away, and they don't need to become an expert and think like, oh my God, why this is so hard, or what should I do? Just keep using it from day one. So that's how we started with this project many years ago. Later, we figured out that there are quite a lot of companies who use these modules internally, and they parameterize them in a way that these modules become ready for some compliance and some certifications. So that people literally take these modules, parameterize certain things. So they wrap these modules with the things. For example, they enable encryption or they enable certain tagging or naming mechanisms, and they use those modules in-house. So I know of many companies who took these modules and they became uh, certified or became ready for some compliance and specifically SOC 2 compliance and HIPAA compliance uh, right away.
That's super interesting. So instead of doing whatever you want with infrastructure as code and potentially doing dangerous things that you didn't really want your developers to do, you use modules, you basically have a wrapper of what you can and cannot do. And by allowing only specific actions that are valid, you limit the chance of doing something wrong. And sounds like this concept helps companies to achieve compliance like SOC 2 and HIPAA. That's really amazing.
Yeah, well, it's also important to understand that what we provide in the open source in Terraform AWS Modules organization is free to use for everyone. So we're
Mhm.
not limiting you from doing totally wrong things. Most likely, if you don't know anything what you are doing, you will implement something incorrectly. But the key point here is that all of our modules are not, well, not all, but most of our modules, I would say, are not wrapped on one small resource, like, for example, SQSQ, you may think, or
Mhm.
SNS notification.
Mhm.
We are usually wrapping many different things which are interconnected, like VPC. VPC itself contains not just of VPC, it contains subnet, routes, route tables, NAT gateways, and so on. So we are wrapping all of this together and providing this for other people who will want to create VPC with a bunch of different parameters specified.
Yeah. Yeah. So you save time and you basically enable the developers to use those resources with all the dependencies and the related resources that are attached or needed in order to operate the main resource that they wanted to. And I'm looking at the GitHub page of the Terraform AWS modules, and this is super impressive for an open source. just looking, for example, on the EKS, Terraform AWS EKS, the Kubernetes service for AWS, it has close this repo alone, not the entire Terraform AWS modules, but this repo alone of Terraform AWS EKS has close to 4,000 GitHub stars and more than 300 contributors. This is super amazing. Are you how do you work with this community of great contributors to your open source?
Well, yeah, that's pretty cool example. I just looked into inside of EKS alone, and there were, or like in average during working days, there are 80,000 clones per day of this repository alone through GitHub. So of course there are a lot of people who are cloning it from their private forks, from their behind firewalls, any other ways. So there are quite a lot of people who are using this stuff. EKS is uh, probably one of not many modules where I deliberately don't put my fingers into, because it's such a big monster that
Mhm.
historically there were, I think, 4 people in total maintaining it over a long period of time. So it's like 1 year on average per person. And now Brian, who is uh, also a core maintainer of all other Terraform AWS modules, is working for AWS, and he is container specialist. So what he does with this module is pretty much his full-time job. So
Oh,
he
wow.
works at AWS, helping customers and helping AWS to be really effective with Terraform. And since we have full control of what exactly we put into this module and how we develop it, he's able to implement features in very quick fashion, answer people questions, and provide best practices. And really, he's the main guy behind this EKS module, at least for last year, maybe a year and a half. I don't remember. Before that, we had other people maintaining it. I mean, when I say maintain it, it's not just like merging any pull request. All of these people who provide pull requests sometimes don't think about peculiarities or different use cases. And very often, when people contribute to the module, they are happy if the use case is implemented. And the job of maintainer, which I think I understood pretty early on, is to be able to say no and protect as much as possible. So I can easily say that there were 50% of pull requests which never made into Terraform
Interesting.
AWS modules, at
Mhm.
least 50%, maybe even more, because people who,
Sometimes you need to be the bad cop.
yeah, exactly. Well, I think it is really uh, important to be a bad guy and tell to people that no, this is bad solution. Please think about it more or implement it differently so that other people can benefit it. I hear quite a lot of frustration from people. Some people say it that I'm doing a bad job because I tell them to. I just don't accept the pull request or the issues are not relevant because well, because I didn't hit them. And in most cases, I think that it is much better to have smaller scope. Maybe not everything is implemented, but at least it's easy to work with it, easy to maintain. And what's most important is that Terraform is not made for easy refactoring. So if we add something like, let's say, even if we add resource with a strange name and we merge it and we think everything is fine, then next time when we add this so next time when person uh, figure out and want to change it, it will be already breaking change.
Mhm.
So we cannot just accept everything and merge everything. That's
Yeah,
why we have a lot of guidelines, which is, well, still not written, but me and Brian know them pretty well. So that's,
yeah. It's really impressive, and sounds like you give a lot of emphasis on quality and not just accepting any commit and any pull request and any issue. And with you cannot argue with success, and the numbers of those repos are amazing. But let's maybe try to summarize, and maybe let me ask you a very direct question. If I am a Terraform developer and I use AWS, is there a good reason for me to use the AWS provider directly and not use prepared, baked, mature AWS modules? Well, what do you think? What? When should I use the modules? When should I use directly the provider code?
well, if you are paid per line written, then of course use resources. If you are paid per hour, of
That's
course.
it. That's a good one.
But if you really want to get job done, implement service you need to use, uh, then the only thing which you will have to do is pretty much understand how this service work. Uh, so somehow educate yourself. Probably go to AWS console, click around, just understand what kind of concepts are there. Then you need to look into example of the module. We always include examples, and we have quite a lot of them showing most of features in different combinations. So will have to run these examples, and you will have to see how things are configured, like what kind of parameters were specified, and what kind of end output you got. So once you have this, then you will have to implement or copy this example into your configuration. If you use Terraform, you pretty much can start with example right away. If you use TerraGrant, we provide some wrappers in many cases, but in most cases, it's not really complicated. And the second point, like benefit, big benefit, is that as soon as you understand how to use at least one Terraform AWS module, you will have zero problems understanding how to use another one, because we always follow the same patterns, same principles, same connectivity patterns between different modules. There are almost never dependencies between modules like inside of it. So all modules are self-contained. They don't have any other external dependencies to other modules. You will have to specify it yourself. Yeah, in most cases, starting from example and understanding how AWS work is enough.
It's amazing to see how the world has changed and now you have everything baked and ready for, let me say, lazy. We are all lazy developers to just use those baked and prepared modules, packages, libraries, what's not. I remember 20 something years ago, I wrote some code in assembly, and now let's how the world has changed. Before we move to serverless TF, Anton, any words you want to say about Azure modules, Terraform modules, or GCP
Oh,
Terraform modules, not just AWS? What do you have to say about that?
oh yeah. Oh my God. I don't remember. I have two people reached out to me recently, and they say like, oh, there is Azure CAF. I forgot what is CAF, but it's like super module. The concept is called super module. It's Cloud Adoption Framework for Azure. And when I looked at this stuff, I mean, two different people reached out, and I looked at this super module, and I was like, oh my God, AWS is 20 years ahead comparing to this one. And the strange part in CAF for Azure, like there are two strange parts. First is that there are people using it, and they are not questioning that they are doing something totally wrong. And second is it's just so fun to see how people are struggling with using it. So for those who don't know what is it, it's like super module is one module which implements all services at once. It's like all services on Azure. You can imagine what kind of complexity is there. So, and people who reached out to me, they asked like, is this even the right pattern? And I was like, no, that's not the right pattern to use.
Who is the maintainer? Is that officially by Azure or is it something by the community?
It's officially by, I guess it's officially by Azure. Yeah, it's officially Terraform super module for Terraform platform engineering for Azure. Oh my God. Anyway, yeah, why I did mention this, I will not sleep today. It's just one of the most complicated piece of software which I saw in yeah
Yeah,
in Terraform at least for
I
some
have to
time.
say, I have to say, what I like about Azure is, among other things, that they do realize more and more that Terraform is relevant for Azure, not just ARM templates and Bicep. If the audience is familiar, ARM templates is the equivalent of CloudFormation, but for Azure, and Bicep is more HCL based for Azure. So they created more and more support in for Terraform, like their
Well,
project AZTFY that was released about a year ago to auto-generate Terraform from Azure. So they are definitely trying to bring more value to
yeah,
Terraform developers.
well, I'm kind of hearing this statement at least for 3-4 years that Azure is finally understanding that Terraform is here to stay. Come on, things are not staying on the same place as it was 3 years ago or 4 years ago. We have moved quite far with AWS modules.
Yep, for sure.
And when I see people struggling on Azure, or even most frequently, they sometimes think that they're doing the right things because, well, they don't look at AWS and they just implement things themselves. And this is one of example where it would be much easier if a company like Microsoft looked into what we have implemented in other places and pretty much steal everything what we did instead of coming up with totally new pattern without taking into account that Terraform is not working for super modules. I mean,
Yeah.
it's not made for this kind of patterns. Of
Yeah.
course, if you
Yeah.
get it up and running, we can help you with that if you want. But yeah, end
Yeah.
users
Not.
are always suffering, and end users, like in my case, reach out to me and say like, we need to add small feature, which is like add small integration between different resources, but we cannot figure out which file to even edit or like what
Oh
should
wow.
we even touch because it's so big.
Spaghetti. Such big spaghetti.
It's
Interesting.
like in
Okay.
total is 169 Terraform files in one. Good luck to understand what's going on there.
Got it. Got it. Okay. So sounds like, back to my question about Azure and GCP. Sounds like you like AWS and you like spending time around helping AWS Terraform developers, at least for the near future. Speaking of AWS,
No, I want to say about Google one thing. I'm not big expert on what Google is doing, but to my mind, Google at least is not uh, reinventing the wheel with patterns like super module. They are doing very pragmatic things for many years. So they have customers, they have modules for services. They have very decent release process. They have even testing framework which they use across modules. So everything is very straightforward. I think the only problem which Google has is that they don't have enough users, so they cannot cover really a very large amount of of combinations. So when customer in AWS open an issue, it happens quite often. I read this issue and I think like, oh my God, what this person was even thinking about? Because his use case is sometimes from different planet. It's like it's valid use case, but it's something what I have never thought even about. With
Hmm.
Google, it's quite straightforward. There are less users, high quality modules
Yeah.
comparing to Azure, so things are much more predictable. And I think it's really the right way.
Okay. Yeah. Good to know. And speaking of AWS, if you're using Lambda and serverless functions in AWS, uh, basically there is the serverless framework by serverless, which provisions the Lambda functions for you, but that's not Terraform. And if you use both Terraform and serverless, sometimes you're starting to have two different frameworks that you need to maintain and different tools to control those. So maybe there is a need for a good open source to do that, or maybe you can tell us about serverless TF a bit more.
Yeah, sure. Uh, well, what is it? Yeah, more than 2 years ago, I was looking into, I was using serverless on AWS using serverless framework. Uh, and that time I was like, okay, I'm doing something what I should not be doing. Specifically, I was
Mm-hmm.
spending time maintaining plugins, fixing something in JavaScript because plugins were written in JavaScript. And I was doing a lot of things which I don't want to do. And since all of my infrastructure was described using Terraform, it was quite natural for me to think about what are the ideal scenario, like how I would implement this using Terraform and using different tools. So I realized that there are at least three different types of tools which I need to utilize. Something like a serverless application framework, like serverless framework itself, and then I need to do something with the infrastructure, let's say to create VPC or to create some security groups, whatever. And then I need to do something with the application. I need to somehow orchestrate the deployment. I need to write some shell script, make file, and maybe use some AWS services to do that. And overall, it was a lot of different tools and a lot of moving parts. So I thought since I already use everything with Terraform and I have a pretty good process around it, it was natural for me to put Terraform in the middle and use Terraform for really comprehensive infrastructure management and performing deployment of these serverless applications as well. So everything is just Terraform files. And I already had quite a lot of Terraform AWS modules available by that time, but there were no modules for serverless. So I developed AWS Lambda function module, which is really uh, pretty much standard nowadays, I would say.
Mm-hmm.
Well, I don't know, at least other big projects people use to deploy Lambda, and not just Lambda, but also Lambda policies. What is it? Authorizers or uh, who can invoke it, what Lambda can do, what kind of integration it can have, like a lot of different resources. So this became part of AWS Lambda module, uh,
Mm-hmm.
and then I developed some other serverless modules for AppSync, for Event Bridge, for
Mm-hmm.
Step Function, for API Gateway, and for some other components which are typically used with serverless,
Lambda.
like DynamoDB database or Aurora serverless.
Mm-hmm.
And yeah, overall, I was using it since approximately April 2021. and I start to kind of popularize this idea that Terraform is good tool, and you can use it for more than just your traditional resources. Use it with serverless, and yeah, so far I know quite a lot of people use it already. Uh, One of the benefit, as I have heard from people, is that they would like to stick to Terraform. And
Yep.
if you stick to Terraform, you don't need to bring half of internet on developer's laptop when they run npm install, because it will be just Terraform init, and it will download just AWS provider, and that's it.
Yep. Makes sense. Awesome. Anton, it was a great pleasure having an expert like you today on the show. Not just an expert, a great contributor to the open source community, especially around AWS, especially around Terraform. So, if somebody in the audience thinks about AWS or Terraform, you should think about what Anton Babenko has to say about that topic. Your project with AWS Modules is so impressive, such big community, and also serverless TF. Very great initiative. Anton, thank you so much for joining today on our episode. And that's a wrap for today. I am Ohad Meislish, and if you like this episode, feel free to follow us at the infrastructure, the IaC Podcast, or visit our website at theiacpodcast.com. Thank you so much, Anton, and have a great day, everybody.
Thank you very much, Ahad.